friends, hi everyone, welcome back to my channel Sarvani Ideas Quest. So in our previous classes we are dealing with the topic models, and in models we have done with two models called probabilistic model and geometric model. Finally now left with logical models. So today our topic will be logical models. Now dealing with the definition of logical models divide the instance space, that is the set of all possible or allowable instances into segments. Finally, the goal is to ensure that the data in each segment is homogeneous with respect to a particular task. Now, consider an example. If the given task is a classification, okay, just consider if the given task is classification, then we aim to ensure that each segment contains a majority of instances of the same class. Okay, now to let you know clearly about what is the definition of this logical models, before that we have to clearly understand intuition behind logical model. Okay, after getting to know the intuition only we can clearly understand the definition of logical models. Before that, if I say you line by line, if I explain you clearly also, you can get my point clearly. Okay, so before that intuition, I just want to say, like, we have some standard points in logical models, so we just deal with them first. So firstly, in logical models, when comparing to both geometric and probabilistic models, according to their intuition, both grouping geometric and probabilistic model, when comparing with both the models, comparing with the single logical model. So now logical models are very easily understandable by human. Why? Because here in logical models, that model is simply converted as rules. Okay, simply they are converted into rules, and then these rules are simply understandable by humans. Now that is the first point. Second thing is, instances are easily organized in a tree structure called feature tree. Now let me show you how a feature tree look like and what are the instances. Now as you guys already know, I think so, instances are placed in terminals, right? And then we have some boolean values, 0 or 1, yes or no case. And if it is yes, then I'll be representing with a rectangular things. And if it is no, 0, then again we go with some other some other feature, right? So next again for that we go with boolean cases 0 and 1. Then we left with some leaves. So this is how a feature tree looks like. It's called a feature tree. Okay, so now here these things are known as features. Fine. Now according to this feature tree only, we'll be giving our instance space. So here these rectangular things are called as segments or simply known as leaves, and these are known to be features. According to these features, we will be getting an instance space. Fine. So now features are used to iteratively partition the instance space. That is what I said now. Features are used to iteratively partition the instance space. So we'll be dividing the instance space, right? So how to give that partitions? We'll be giving divisions. We'll be giving these partitions. So we'll be doing these partitions according to features only. Okay. Now the leaves of the tree therefore correspond to rectangular areas in instance space called instance space segments. Now depending upon the task we are solving, like how we can label the leaves with a class or a probability or some real values, so many. Okay. Now feature trees whose leaves are labeled with classes are commonly called as decision trees. Feature trees whose leaves, okay, like feature trees whose leaves are labeled with classes. These leaves are labeled with classes, so that tree is known to be decision tree. Fine. Now here mostly we can encounter with the boolean values in this model. As we said, we have 0, 1 cases, yes or no. Most appropriately, models for logical model is a tree based model. So here we have binary valued trees, right? So now as I shown you clearly all the things, now we undergo with the construction of, like, how do we deal with feature tree, and how do we do the construction of instance space with a feature tree using features and instances classes. Okay, so now Let me first consider a feature called, I just take two features called bonus and lottery. Okay, so my first feature I just consider bonus. With this bonus I just undergo with two boolean cases, 0 and 1, and if bonus is not present, that is the value 0, so then I just consider with any other value. Now bonus is present, I just took a class rectangular segment, so that I'll fill with spam and ham classes, and I'll give spam class as 20 and ham class as 5. Then if the bonus is not present, then I'll check with any other any other feature. Again we'll be undergoing with boolean values, and then I'll be representing the leaves. So heading this with spam ham classes with 20, 40. Okay, so this is how I just constructed as myself. This is a simple example of a feature tree, how it looks like and how we can construct it. Now we have to say, according to this, if bonus is not present, then I was undergoing with some other feature. If bonus is present, then what is the class we have to derive? According to the majority. Here majority is what always remains in logical model. That is why it's simply our first rule is majority, right? See here, majority of instances. So according to here, my spam class is a majority case, so this leaf will be a spam class, and here it's a ham class. Hope you guys are understanding, and here it results in spam class, right? So this is how we construct a feature tree, and then we can derive some classes. Now according to this, we'll be constructing a instance space. In instance space, we just have a rectangular segment, right? So sorry, I just draw some other. So why I draw it like this means, I just say you. So we have two features, bonus and lottery, right? Yeah, here it is 0, this is 1, 0 and 1. So here now according to this case, so here if bonus is 1, okay, if bonus is 1, then spam values are 20 and ham will be 5. Okay, we just don't have any other case like 1 case, right? Because firstly this we have we'll be having 4 quadrants like this, right? How we will be dividing these quadrants according to features, right? So now this is a quadrant of 0, 0. This is a quadrant of 0, 1. This is a quadrant of 1, 1, right? 1, 1. So heading to this, we just only have 1, 1 with entire quadrant. Both the quadrants will be same because we don't have any other case of this here, right? Here we have a single space. So however, it's just a incomplete feature tree, okay? As this is an incomplete feature tree, here both the quadrants remain same. Now according to this, when we have 0 and 0, when bonus is 0 and lottery is also 0, bonus is 0, lottery is also 0, then our spam will be 20 and ham class as it's represented. And when lottery equal to 1 and bonus is 0, okay, bonus is 0, lottery equal to 1. So this is how we give our instance space partitions. Fine. So hope you guys are cleared. Now according to this, how we get the majority things here in 1 on 1 majority. So this both the quadrants belongs to spam class, and here this quadrant belongs to spam again, but this class belongs to ham class. Okay. So now as I already stated, logical models are very easy to understand, as they are very simply converted into rules, and those rules are simply understandable to human. Why? Because especially here when we deal with these Boolean or binary trees, we represent them with some if-else statements, if-else conditions. As I already said, these will be converted into rules, right? So now let's see how these will be converted into rules and how we write those rules according to the feature trees. Okay. Now, just consider this tree only. I'll be doing with this tree only. So if bonus equal to 1, the case if bonus equal to 1, then the class is spam, right? Then we write it, then class equal to spam. Or if else the case is 0, if bonus equal to 1, then the class is spam. Now simply to state these two cases, now how we'll be writing this? As we already know, in C language we get to know this if else if statements, right? So if we write this rule as like if bonus equal to 1, then class equal to spam. Then if loader equal to 1, to state this class, like that. Then we'll be writing it as else if loader equal to 1, then class equal to spam, right? Now we just left with single thing. We have done with both the cases. Now we have left with single thing. Now we can simply write this as else. Now if bonus equal to 1, then class equal to spam. Else if the loader equal to 1, then class equal to spam. Now we have left with single one. Now we can simply write this as else class equal to ham. Hope you guys are understanding this. How we'll be writing the rules. Okay. So this is how we can simply write the rules, converting the feature tree into rule. So tree learning into rule learning. Okay. So this is why it makes easier to code and as well as to understand to human. Okay. So the main rule here we always call in logical model is ante logical models అని తెలియంగానే మనకి ఫస్ట్ రావాల్సిన పాయింట్ ఏంటంటే మెజారిటీ క్లాస్. This is what the only approach we follow in logical models. Okay. So till now we have done with incomplete feature tree, right? Now let's deal with let's consider a case with a complete feature tree. Then while dealing with the complete feature tree, what are the cases will be arised? And so to complete with the complete feature tree, now how to take the measures when we come across with some of the bad situations. Okay. Now let's do that. So now I consider a tree like my first feature is bonus, then again dealing with the cases 0 and 1 boolean tree. Then my next feature is lottery. If it is case 0 also it's lottery, and if it's case 0 if it is case 1 also I'll be taking lottery only. Again given with two situations 0 1 0 1. Then my leaves will be so we'll be getting 4 leaves. According to this, when bonus equal to 0 and lot equal to 0, then I'll be assigning the spam as 20 and ham as 40. Here spam equal to 10 and ham equal to 3. I just considering this. Okay, so spam equal to 40 and ham equal to 4. Spam equal to 0 and ham equal to 10. Fine. Now this is a complete feature tree. Okay. Now while dealing this, so what are the majorities for this particular class? For this particular instance, we have to find what is the basic majority class. So that class will be labeled our class label, right? So here according to this is a ham class. So for this entire thing, this will be a ham class labeled. Okay, it's a ham class. Now for this it's a spam. Here also it's a spam, and again here it's a ham. Now for this we'll be doing instance per segment. How we'll be getting that? So for a complete feature tree, then we'll be filled with all entire 4 quadrants. Okay. So now it's this is 0 1 0 1. This will be bonus, and this is lottery. As this is a 0 0 quadrant, it's a 0 1 quadrant, 1 0 quadrant, and this is 1 1 quadrant, right? So in 0 0, when bonus equal to 0 and lottery equal to 0, then the class is ham, right? Spam equal to 20, ham equal to 40. So the class is ham class here, right? Accordingly, spam equal to 40, ham equal to 4. Then the class is spam class. So in 1 1, bonus equal to 1 and lottery equal to 1. So then spam equal to 0, ham equal to 10. Then the class is ham class. So 1 0 as so here lottery equal to 1, bonus equal to 0. Okay. So then spam equal to 10, ham equal to 3. Then the class is spam class. Hope you guys have understand this instance space segment also. So this is how logical models will work. Now let us start how to write the rules according to this feature tree and instance space. Okay. Now also here we can use two conditions at the same time. Like, so if bonus equal to 0, okay, as if bonus equal to 0 and lottery is also 0. This is what the case, bonus equal to 0 and lottery is also 0. So bonus equal to 0 and lottery equal to 0, then class equal to ham class, right? Bonus equal to 0, lottery equal to 0, then the class is ham class. That is what the statement I just write here. Again, else if, as if this is the case, we have done with the first case. Now here both the cases are spam classes only. Both the label classes are spam classes only. So then how will be writing the statement? Else if statement now. Okay. Else if bonus equal to 0 or lottery equal to 0. Or in the sense either one will be the case, right? That is why we are representing this as or. Bonus equal to 0 or lottery equal to 0. If bonus equal to 0 or if a lottery is equal to 0, then both the cases result in spam classes, right? Then class equal to spam. Now only we have left with this one thing, single thing. We have done with 3 classes, left with single class, right? So now we can simply write this as else class equal to ham. Okay, as else class equal to ham. Hope you guys are understanding this. First rule is if bonus equal to 0 and lottery equal to 0, that is the case. Bonus equal to 0 and lottery equal to 0, then that the class ham. Now we'll be writing OR case. Why? Because here both the cases of the classes are labeled with spam only, right? So either if bonus equals 0, bonus represents 0, or if lottery represents 0, then both the classes will be spam. That is why representing with OR. Okay. Then we have left with a single case. So simply we can write else class is ham, as we are done with rest of the 3. So this is how we deal with writing the conditional rules. Okay. But also while using conditional rules, okay, now we have just done with conditional rules, right? Also while using the conditional rules, we may have one disadvantage, which is called overlapping. Okay, so how this overlapping occurs and how to deal, now let's see. So to check that overlapping condition, how to check that overlapping, like consider the case if bonus equal to 1, then class y equal to spam. I just consider the case. And if Harry equal to 1, then class y equal to ham. Here we just have different features. Okay, so they are not they are independent statements. They are not dependent, right? So now in this case, we can draw an instance space like okay, let me undergo with some colors. Okay, here I will use some colors. Now if we plot according to these rules, then as we have Harry 0 and 1, and this is bonus 0 and 1, right? So now according to these rules, if bonus equal to 1, then we color that accordingly. Okay, then it says the class spam, right? If bonus equal to 1, then I was doing the entire coloring here in bonus equal to 1 case, right? Now second case, if Harry equal to 1, then class equal to spam. According to Harry equal to 1, I'll be coloring the entire Harry equal to 1 space. So then So we have colored according to the conditions. Now it is giving some contradictory results, right? Because the condition 1 says it's spam and the condition 2 says it's ham. By this, it gives a contradictory result as it is overlapping, right? This is what the case it is, overlapping. So now, these are the cases where we undergo with some disconnected statements, okay? When we undergo with some disconnected statements, like while we didn't give any proper statement, then we may end up with this overlapping. And also, we are left with some entire quadrant, like we are left with this entire quadrant. We didn't even touch this, right? So this is how the cases arrived. Like while we deal with conditions also, we have to check very clearly without getting this overlapping situation. So this is what the only point we have to keep in mind, because while we are dealing with the logical models, that too with conditions, we have to be very sure that not to come across the overlapping. So to avoid this type of overlapping situations, we have to make use of a single rule. Okay, so a single rule throughout the model. This is what the only case we have to do in order to left out this overlapping situation. Now, so till now we have done with done with both the complete and incomplete trees, right? So now I think we guys get to know how to construct the feature tree and how to construct the instance space segments, how to deal with them, and how much the logical models are very easy to understand, how we can generate the rules, right? Now what we have to learn is, like, we just have learned according to this logical model both a tree learning and rule learning. We have done with both tree learning and we have done with this rule learnings, right? So we just implemented these in a top-down fashion only, right? We just implemented the trees in a top-down fashion. According to that top-down fashion only, we have done with the rule learnings also, right? So now let me clear you about how tree learning and rule learning separately, okay? So in tree learning, what we have done, we just undergone with the top-down fashion, right? Because here, see, in tree, firstly, we have just considered a feature and then we just split those features in order to get a feature tree. So we just worked on in top-down fashion, right? So that is what the first point. In tree learning, firstly what we have done, work in a top-down fashion. Next, what we have done, so the first task, now what we have done here, that is what I already said. We just find a good feature. So from that feature, we just split the tree, right? So then while finding the splits, that improves the results of the purity. Purity in the sense, purity of the next level nodes, right? We just improves the purity of the next level nodes. That forms a degree, okay? So the purity refers the degree of next level, which says that nodes that belongs to some particular class maintaining to the degree, okay? That is what we have done. So the next task is we just find a good feature. In order to split a tree. To split a tree. So now splittings improves the purity results. That means results of next level nodes. Okay. So then by improving the results of next level nodes, so that purity that refers degree. So purity refers degree of the tree. So the degree that belongs to degree says that the purity of the node belongs to some particular class. So that belongs to some particular class. That means class that maintains the degree. Okay. And next, finally, what we have done now, when we finding such feature, when we find a good feature, finding such feature that found, we just dividing our like by the feature only we have constructed our feature tree, right? By this features only we are creating an instance space segment. So we'll be dividing that instance space segments, right? So how do we divide these rectangular hyperrectangles, right? So we just follow this through a divide and conquer algorithm. So to divide, we follow divide and conquer algorithm to give the partitions. Okay. So next, from this training set only. Okay. Now like from this now this feature tree will be our training set, right? From this training set, how do we divide this instance like hyperrectangles? We just divided things. So then we are giving with some particular partitions. So for that we follow divide and conquer algorithm, right? So this is how finally we done with tree learning. Okay, now let's continue with rule learning. So in rule learning, what we have done now in rule learning, I just what I do is I just clearly explain what is the situation till now, what we have undergone with the situation till now. Okay, so when we are making with rules, when we are doing with conditions, we just have a condition called we just have a bad situation called overlapping, right? So we just have two conditions. What is the conditions? Yes, we have these conditions. If Bon is equal to 1, then class equal to spam, and Harry equal to 1, then class Y equal to ham, right? Suppose this is the position, like we have an email that contains both of these words, bonus and Harry. Then according to the results, according to these results, it is ambiguous, right? The situation is ambiguous. That is, we can't say clearly that particular email belongs to spam class or ham class, right? So in such type of rules, it is known to be an inconsistent or incomplete rule. It is the case, that means bad or overlapping situations can be known as inconsistent and incomplete, right? So hope you guys are understanding this tree learning and rule learning, why I was discussing, because I was just saying you these points for your note purpose only. Okay, these are just for your notes purpose, because when you have a situation to give it for 2 marks or 5 marks, so for that you need a points. So I was just giving you the points to jot down for your notes. Okay, so now just what the case where here an email containing both the words like bonus and Harry, right? So we can't decide the email that either it is belong to spam class or ham class. In such cases of incompleteness, we add a default rule. Okay, so for this we add a default rule in order to predict the cases. That means in order to predict according to the majority class. Cases in the sense that will be done according to majority class only. As I already said, logical models finally results with only point majority class. That is what, so how this is results in tree learning and rule learning. Almost we have done with our logical models. Now I just close today's class by saying the advantages of logical models. So advantages in the sense, as I already said, it is very easily understandable to human. Easily understandable, right? Because because the model itself can be easily inspected by humans, right? That is why it is easily understandable. And why it is easily inspectable by humans? Why? Because that is what our second point. It just provides the explanation. Explanation for its predictions, like for the predictions, which is simply called as a declarative part, right? Declarative. So these are our advantages about logical models. So hope you guys have clearly understand the topic logical models, and if you have any doubts, please feel free to comment me below.